Hello, today we're going to be going over merge sort. So what is merge sort? So it's a sorting algorithm. And it sorts by dividing and conquering. So what does this mean? Well, first you divide an array into subarrays, and you keep becoming smaller and smaller and smaller until you're down to one element per subarray. And then you merge these subarrays back together. Sorting them as you go. Until you're back to the big array. Alright. So let me give a brief demonstration. So say you have the array 58, 22, 34, 7, 15, and 6. So we're gonna split this down the middle first. So 58, 22, 34, and 7, 15, 6. So we're gonna split this down the middle again. So if you have an uneven number of elements in your array, you can pick like either the left side of the array or the right side of the array to have the extra element. I will just be going with the left side of the array. Yeah, and all you have to do with that is just like keep it consistent. So I'm splitting it in half here and half here. So we have 58, 22, 34, 7, 15, and 6. Now we have to do one more splitting. So and we can just bring this 34 down since it was already split. And same goes for the 6 as well. Okay. And now here is the part where we start making our comparisons and bringing them back together. So let's see. So we have 58 and 22. So 58 is greater than 22. So 22 will be the first element in the subarray, and then it will be 58. And we just bring the 34 down again. And now we combine back 7 and 15. 7 is already less than 15, so they're both in the correct spot. And we'll just bring the lonely 6 along. Okay, let me rewrite this up here. So So now we combine these two subarrays. So 58 is greater than 34, but 34 is greater than 22. So it goes into the middle of these elements. And now we combine these two subarrays. So 7 is greater than 6, but 6 is less than 15. So yeah. So 6 goes all the way at the end. Now we do another combination. So the elements are already all in order, so with any comparisons, you'll see that they just need to be combined properly. There you have it. This is our sorted array. So, yeah. And let me show you the code for this. So for merge sort, there's two methods for this. So the first method is the main merge sort method. It recursively calls itself to you know, divide the array, and then it will also call merge to sort the subarrays that it divided into. So the inputs for this are an integer array, which is the array to be sorted, and integer I, that's the starting index of the array, like what part of the array you should start sorting at, and integer j, that's the ending index of like what part of the array you should sort at. So since this is a recursive function, it needs an exit condition. So this is the exit condition at the top here, the first line. So if a subarray has only 0 or 1 elements, then you can exit the method because like it's already sorted. So after that's checked, you have to calculate the midpoint of the array. So that midpoint is where you're gonna split the array into two smaller subarrays. So this is where the recursion comes in. So this recursive call will go into the left half of the array, and this recursive call goes into the right half of the array. So the left half starts at index I, so the very first element of the array, and it ends at mid. And the right subarray, it starts at the next index after mid, and it ends at the very last element of that array. And then the merge function is pretty self-explanatory, but like it takes the two subarrays and merges them back together, but sorted. So let's get into that. Yeah, this is the merge method. It merges. So the inputs it takes are the array that's going to be sorted. A and B are the start and end indexes of the left subarray, and C and D are the start and end indexes for the right subarray. So we copy the contents of both subarrays into L1 and L2 respectively. So L1 contains the left half contains the left subarray, and L2 contains the right subarray. So then we enter this while loop. So in the while loop, we have to keep track of 3 things. The I keeps track of the current index of L1, J keeps track of the current index of L2, and K keeps track of the current index of A. So that's going to be where the merged elements go in the new bigger array. So to leave this while loop, we have to constantly check if one of the arrays is empty, and when one of the arrays is empty, that means there's nothing left to compare because you can't compare nothing to something, so you leave that loop. But while we're still in this loop, we first start by comparing the elements at index I and at index j. So if the current element from L1 is less than the current element from L2, you put that into the bigger array next, and then you increment I by 1 so you can take a look at the next element in L1, otherwise the opposite is true. So you put the current element from L2 next into the array, and then you increment J to go and look at the next element in L2. And after that, make sure to increment K to go to the next index in the array. So you can have the next element to put in there. And these two smaller while loops, they just copy any leftover elements from L1 or L2 that may happen, like just in case one of these arrays empties out first before the other one. Yeah, and that's pretty much it. So all we have to do in the main method is just call for merge sort, and it will do its thing. Okay. And one last thing is the time complexity. So the time complexity for merge sort, let's figure this out. So in merge sort, there's n values that must be sorted. The operations that must be done for merge sort are splitting, like into subarrays, and then the merging is in the name. So the number of splits that must be made to an array to make it into n subarrays n minus 1. It's like how if you want to cut like a candy bar into 4 pieces, you have to make 3 cuts. See? Yeah. And for merging, you also have to make an equal amount of merges. To make up for the splits. So you also have to make n minus 1 merges. And for the number of comparisons needed, well, the structure of the merge sort, the levels of it, it can be described by log base 2 and levels. If you draw it out better than I did during the example, you can see this. So if there's log n levels, and there is n minus 1 comparisons at each level, which we can simplify this to n because we only want the most dominant term. This means that in total, during the whole of merge sort, there are n log n operations, comparison operations. So let's combine the split and merge operations. Oh yeah, the comparisons were part of the merging operation because, well, you saw the code. So when we compare the split and, or when we combine the split and merge operations, we get a time complexity of O of n minus 1 plus n log n. However, n log n, this is the most dominant term. So we can simplify this into O of n log n. And this is why merge sort has this time complexity. And the time complexity for all cases is O of n log n because merge sort is going to do its thing whether or not like whether or not the array is sorted well or not. Like it's still going to split everything down to one subarray and then bring everything back together. If that makes any sense. So yeah, this is merge sort, and yeah, that's it. Thank you.